Ever wondered how developers build those massive, complex apps on your phone without them just collapsing into total chaos? Well, the secret isn't just about writing code. It's about having a powerful blueprint. It's called Object-Oriented Programming, or OOP for short. And today, we're going to break it all down. All right, so here's our game plan. We're going to start by taking a quick trip back in time to see what the world was like before OOP. Then, we'll dive into the 4 core ideas that completely changed how software is built.
You know, to really get why OOP was such a revolution, you first have to understand the problem it was created to solve. And honestly, it was solving an age of pure coding chaos.
I want you to imagine something. What if you tried to build a skyscraper, but you had no blueprint, no plan at all, just one single massive list of instructions for every single brick, every wire, every window? That's pretty much what early programming was like.
This old-school way of coding, called procedural programming, was fine for super simple tasks, but as programs got bigger, they turned into a tangled mess of what developers call spaghetti code. You change one little thing over here, and suddenly something completely unrelated would break over there. It was a total nightmare to manage, and reusing any of it was basically impossible. And that's exactly where OOP comes into the picture. It wasn't just a small improvement. It was a totally new way of thinking. It was the architectural plan that software desperately needed. So the first big idea you've got to get is the class. A class is the master blueprint. Let's stick with our building analogy. The class is the blueprint for a house. It defines all the things a house should have, number of rooms, color of the walls, and all the things a house can do, like opening doors or turning on lights. But here's the key. It's not the house itself. It's just the plan. So if the class is the blueprint, then an object is the actual physical house that you build from that blueprint. And what's cool is you can use that one blueprint to build a whole neighborhood of different houses. Each house is its own unique object. One might be blue, another red, but they all share that same core structure and functionality from the original plan.
Okay, so we have our blueprints and our houses. How does OOP stop this new neighborhood from becoming a chaotic mess? Well, that brings us to our very first pillar, encapsulation. This is all about keeping things neat and tidy.
The best way to think about encapsulation is like a protective shield, or maybe a capsule, for your code. It bundles all the important data for an object and the code that works with that data into one single, self-contained unit. And this is a huge deal, because it stops other parts of the program from just reaching in and messing things up when they're not supposed to. And here's the clever way it's done. Coders will mark the object's data as private, basically hiding it from the outside world. Then they create these special public functions called getters and setters. Think of them as security guards. They become the only official controlled gateways from accessing or changing that hidden data. You have to go through the proper channels. All right, our next pillar is abstraction. And if encapsulation is about keeping things tidy, abstraction is all about keeping things simple by hiding all the complex, messy details we don't need to see.
It's exactly like driving a car. To make the car go, you don't need to be a mechanical engineer who understands internal combustion. Nope. You just need a simple interface. The steering wheel, the gas pedal, and the brake. That's it. Abstraction gives you that simple interface for a really complex system.
Because let's be real, while you're just gently pressing a pedal, there is an incredible amount of complex machinery whirring away for you, completely and totally hidden from view.
And that's abstraction in a nutshell. It hides all of this complexity. In programming terms, it separates the what from the how. It means you can interact with an object based on what it does, without ever having to get bogged down in the nitty-gritty details of how it does it. It makes code so much easier to work with. Next up is inheritance, and this one is a massive time saver. It's a powerful idea that lets us build new classes based on existing ones. It's pretty much the ultimate don't repeat yourself principle in action. Inheritance basically creates a family tree for your code. You have a parent class and a child class. The child gets to inherit all the properties and behaviors from its parent for free. So, for example, you might have an animal class. Then you could create a dog class. Well, a dog is an animal, right? So the dog class automatically gets all the animal stuff, like eat and sleep, and then it can add its own unique behaviors, like bark. It's a brilliant way to reuse code.
And that brings us to our final pillar. And it's got a big, fancy name, polymorphism. But don't let the name intimidate you. The core idea is actually beautiful and simple. It literally just means many forms.
So many forms. In the world of programming, this means a single action, a single name, can have many different outcomes or behaviors depending on the situation. It's the ability of an object to take on many different shapes, so to speak.
And here are the two main ways this plays out. On one hand, you have method overloading. This is where you can have methods with the exact same name, but they do different things based on what kind of information you give them. Think about how a plus sign can add numbers, but it can also join two pieces of text together. Same sign, different job. Then you've got method overriding. This uses that inheritance idea we just talked about. If our animal class has a make sound method, the dog child class can override it to make it bark, while a cat child class can override that same method to make it meow.
So after all of this, after laying this whole foundation with classes, objects, and these four big pillars, what's the final payoff? Well, it means we can finally build that digital skyscraper we talked about at the beginning, and we can build it right. The difference here is night and day. OOP takes us from writing one long, fragile scroll of instructions to assembling strong, reliable, and reusable components. It's like going from building with mud and sticks to building with Lego bricks. This is what lets us create the incredibly complex yet stable software we all use every day.
So here's a little challenge for you. The next time you open an app on your phone, try to see it through this new lens. That user profile you're looking at, that's an object. A post in your feed is an object. Even the like button is an object. They all have their own data and behaviors, all interacting based on this secret blueprint. And trust me, once you see it, you'll start seeing it everywhere.